All right, that's a short little video here, one for displaying quantitative data using stem plots. So you might have called these stem and leaf plots before. So we're going to use the word stem plot. Very short section, not a huge deal in this class, but wanted to show you another way to show your data. All right, so here's what these stem plots look like. All right, so a stem plot, its stems consist of all but the final digit. The leaf is the final digit, and the stems are ordered from least to greatest in a column, and then the leaves are arranged in increasing order from the stem. So over here, so this 1 through 4, those are the stems. It's terrible, I'm sorry, stems. And then over here, all of these numbers, those are the leaves. So notice these stems are put in numerical order, 1 to whatever. Notice that these have a couple repeating stems. This is an example of split stems. We'll talk about splitting stems down here. Sometimes you do that, sometimes you don't. Again, it's just to avoid, like this 2 would be super long and huge. So it's just a way to avoid even longer lines of leaves. And then the leaves, notice from least to greatest on that bar, least to greatest going out. This is very important. You must have a key with every stem plot. That is how you read the stem plot. So it gives you an example. It says 2 bar 8. So 2 bar 8 means the soft drink contains 28 milligrams of caffeine per 8-ounce serving. Okay, so again, 28 means that the 2 is the stem, and that's the tens digit, and then all the leaves represents the ones digit. Sometimes these are percentages, sometimes they're decimal numbers. So be very careful when you look at the key. Now, again, as I said, note sometimes we get a better picture by splitting the stems. There's no magic number of stems, but you want to have at least 5. So say like you only had, 10 through 30, right? That would only be 3 stems, the 1, the 2, the 3. So split them, and now you get 6 stems potentially. And then again, if you're splitting stems, assign equal number of leaves. So typically it's just in half. So 0 through 4, the first 5 digits, and then 5 through 9, the second 5 digits. All right. But again, we're not going to do so much building it. We're going to just interpret them. All right, cool beans. Okay, so here's our example here. So it says, to become president of the United States, a candidate does not have to receive a majority of the popular votes. The candidate does, however, have to win a majority of the 538 electoral votes that are cast in the Electoral College. So again, in 2016, Hillary Clinton actually won the popular vote, but Donald Trump won the Electoral College. So again, it's just how our system works. And again, it's up to debate on how it should really be. The stem plot shows the number of electoral votes in 2016 for each of the 50 states and the District of Columbia. Use the stem plot and the data table from the previous example to answer these questions. Well, there's no data table from the previous example, so use the stem plot to answer these questions. There we go. Sorry, I fixed that. Okay, so use the stem plot to answer these questions. So notice here we have split stems, right? And again, look at your key. 1/5 is a state with 15 electoral votes. So it says, what percent of states get 10 or more electoral votes? So we need to look at our stem plot. Where would 10 be? So 10 would be right here. 1, 0. This is your 10. So 1 and 0. So we want 10 or more. Well, if I look here, there are 50 states and the District of Columbia. There should be 51 numbers there. So I'm going to count all of these leaves from this 0 all the way down because it's 10 or more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 numbers there. 1, 2, 3, 4 numbers there. 2, 2, 1, and 1. That's 11, 15, 17, 19, 20. That's 21 numbers, 10 or greater. So 21 out of the 51. Times that by 100, and that'll give me my percent. All right, so it's going to go away. So we can go to Desmos Graph and Calc and get this done. So we do 21. Desmos Graphing Calculator right here. We do 21 divided by 51 times 100. And that's 41.17. I'm going to round that 17 to 2, right? 7 makes the 1 become 2. 41.2%. Next, it says describe the shape of the distribution. So remember, when we do shape, we talk about 4 potential things: the shape, the peak, the any clusters, and any gaps. So what is the shape of this data? Well, it looks like the peak is right here. And again, if you turned this stem plot sideways, right? So think about this: 0 would go here, the stem, and then 5 would go here. So this peak is right above the 0. So there's only one set of leaves on that 0, and then you have a whole bunch of leaves over here, right? So this is skewed to the right because the right tail is longer. So for a stem plot, if it's longer down, that means skew to the right. If it's longer up, skew to the left. This is longer down. So skewed to the right. We're looking for the peak now. And again, for this, you have to give me a range. So the peak is between 5 and 9 electoral votes. And I'll just put EV for electoral votes. Then I'm looking for any clusters. Well, really, I mean, the whole thing's a cluster, right? So, I mean, from 3 to 29. So you could say that, but really, that almost all the data values are clusters. And then any gaps. And again, I don't know. There's two gaps. I mean, from 29 to 38, and then from 38 to 55. Okay. So that would be describing the shape. Great. And then it says which two values appear to be outliers. Well, of course, it's these two by themselves, right? That are around the gaps. And we have 38 electoral votes and 55 electoral votes. Awesome. So that's how you read a stem plot. All right. So good luck on your